Hey everybody, welcome back. So we're going to talk about heat as a mechanism for controlling microbial growth. Heat is a very inexpensive mechanism, but and it can be used to sterilize or disinfect materials, but it's not always used because a lot of items can't be heated up as high as we need to kill microbes. So that would be looking at the type of instruments we're using. So there are two types of heat that we talk about, moist heat, and then we talk about dry heat. Moist heat irreversibly denatures proteins. Moist heat is actually more effective than dry heat. Boiling can destroy microbes and viruses, but it does not sterilize. It cannot get rid of endospores. Pasteurization destroys heat-sensitive pathogens and spoilage microbes. Again, does not sterilize, cannot get rid of endospores. There are two forms of pasteurization. The most common form that we see in the U.S. is high temperature, short time. So this method is going to heat milk or other objects up to a high temperature. So milk, ice cream, juice. And then it stays there for just a few seconds and then drops the temperature. Whereas ultra high temperature method is able to be used to produce milk and juice that is able to sit on a shelf, so it doesn't have to be refrigerated or frozen. So ultra high method, you heat the milk or the juice up very high to 140 degrees Celsius. You leave it there just for a few seconds and then rapidly cool it. And that allows us to box milk up and set milk on a shelf where it can stay for months. In many countries, this is the preferred mechanism for purchasing milk. So I've been to Germany and Italy, and in both of those countries, their milk is on counter or is on shelves, and apologies for that. Their milk is on shelves, and when you get the milk, you have to put it in the fridge for an hour or two before you drink it. If you like cold milk, it's able to be drank warm or at room temperature, but I know I like my milk cold. It tastes just like any other milk once it's been refrigerated, but it just sits on the shelf so you can store it for weeks and months instead of just for a couple of weeks in the fridge. Another mechanism, if I can get my slide to move, is the autoclave. So autoclave sterilizes using pressurized steam. So the autoclave is what we use to get rid of all of the biohazard that's produced in the microbiology labs. It's what we use to sterilize media before we plate bacteria or before we transfer bacteria to broths or plates. Sterilization is going to occur at 121 degrees Celsius for 15 minutes. So 100 degrees Celsius is boiling. We increase the temperature by increasing the pressure in the autoclave. So this is pressurized steam. And this can get rid of endospores as well as bacteria, but it does not destroy prions. So you have to increase the temperature and the time to hopefully, so this isn't even for sure, but hopefully destroy prions. When we use autoclaves, we're going to, because we want to make sure that it has sterilized, in our autoclaves, we use tape that is heat sensitive. And so when you add something into the autoclave, you put a slice of tape on it, a piece of tape, and when it comes out, if the autoclave tape has changed color, it has these little lines through it, that means autoclaving worked and now everything is sterile. There are also biological indicators that can determine if the autoclave worked or not. We don't use those in our labs. The commercial canning process, it uses autoclaves as well. These autoclaves are super large and they're known as retorts, and they are designed to kill not just regular microbes but endospores, specifically endospores like the endospores produced by Clostridium botulinum, which tend to grow in canned foods. It can reduce these microbes from 10 to the 12th endospores to down to only 1, and the likelihood of having that many endospores in any environment is almost impossible. So it's getting rid of all of the endospores. The reason we need to get rid of endospores is endospores can germinate in foods that are canned, and that can allow like botulinum toxin to get into the body, and botulinum toxin is deadly. There are certain types of endospores that could potentially survive the retort, but in general, these are not going to, they grow only at very, very high temperatures, and we don't tend to eat our food at that high of a temperature. All right, I'm going to stop here. I'm sorry, I just clicked over the heat. I'm going to stop here, and we're going to talk about dry heat and filtration as well as irradiation in the next video. All right, bye.